Hi everyone, welcome to this video. In this video, we will be talking about Java class loaders. Now this is going to be a two-part video series. In the first part, we will be focusing on class loaders in general, how they work, and the basic flow of how classes are loaded in Java. In the second part of this video, we will be focusing on custom class loader. So we will see what is a custom class loader, how can we create our own class loader, and how can we use that class loader to load the class files. So let's start. Before we deep dive into the class loader, we need to understand how does JVM run the code that we give it to run. That means when we write a Java program and when we compile that Java program, it generates the .class file, it generates the bytecode for that Java program that is eventually executed by the JVM. But think about it, how does it run that code? How does JVM run that code? How does it execute that class file or the bytecode? Now, in every Java program, there is a class, the entry point of that program that has the main method. So what JVM does, it finds the class which has the main method, public static void main, the method that we always write, and then it loads that class. The first class that it loads is the class that has the public static void main method. And then it starts executing the code from that point. Now we come back to the same question, how does it load that class? And the answer is using class loaders. So what JVM does, it uses a class loader to load a class in order to run or execute the code that is written in that class. So what is a class loader? Java class loader is a subsystem of the Java virtual machine which is responsible for loading Java classes into JVM at runtime. So Java class loader loads the class from the file system. It can load a file from the network or any other sources. And it creates a class object in the memory that can be used by the JVM to run the Java process. Or whatever program we have written, it will be executed by JVM. But first, it needs to load the class, and it does that with the help of a Java class loader. All right. There are different types of class loaders, as you can see on the screen. So number one is the Bootstrap loader. Second loader is basically which is called extension or platform loader. Third in the list is application or system class loader. And the last one is the custom class loader, which we are going to see in the part 2 of this video. So let's start from the first one, Bootstrap loader. This is the primordial loader. This is also called the primordial loader. That means it has no parent. Bootstrap class loader is the class loader which is responsible for loading all the core Java classes and all the libraries from JDK and JRE. It loads all the classes which is required by the JVM to start its own execution. So when a Java application starts up, the Bootstrap class loader is the first class loader to be invoked by the JVM to basically load all the required classes. All right. Then comes the extension or platform class loader. This class loader is responsible for loading the classes from extension directories. So we can define the extension directories using the system property or the VM argument, which is java.ext.dirs. Extensions are basically optional packages that can be added to JDK or JRE to provide some additional functionality. So if we define a directory using this VM argument or system property java.ext.dirs, then what JVM will do, it will call the extension or platform loader, which will read the files from that directory, and those files or those Java files or Java classes will be loaded into JVM. So that is extension or platform class loader. Then comes the application class loader, which is also known as system class loader. This class loader is responsible for loading the application classes. The class files or Java files that we write, these class files are loaded by the application class loader. If we talk about the application or system class loader, how does it find the classes that it needs to load? How does it know the classes that were developed by us? So it does so with the help of the class path VM argument, which is -cp or -class path. And this class path VM argument is generally provided by us either explicitly when we are using javac command or indirectly via a build tool like Maven, Gradle, or maybe if you are using an IDE like IntelliJ or Eclipse, and when we run that program under the hood in the backend, they will provide or they will pass this class path accordingly. So it all depends on the class path as long as the third class loader is concerned. So in the class path, we provide the classes which we write, which we develop, and that's how application class loader finds the classes that it needs to load. But the point here is that application class loader loads the classes developed by us. All right. Then comes the custom class loader. It means if we need to do something extra, maybe we need to load duplicate classes, or if we need to have some isolation in the class loading process or any other reason, in that case we can create our own custom class loader, which we will cover in the part 2. Moving on, we may have a single Java file or a single Java class in our program, or we may have hundreds of Java files in a huge project. So does that mean when we are running the Java program, when we start the execution of a Java program, will it load all the classes that it finds? Well, the answer is a class gets loaded when it is first referenced by a running program. What JVM does, it follows a lazy loading strategy, which means it will not load all the classes in the system, but it will only load the class that are required by the program at runtime. So when we run a program, we generally give the class file which has the main method. So at first, only that class will be loaded. So JVM will load that class and it will start executing the code written in the main method. In the main method, if that class is referencing any other class, at that point of time, it will try to load that other class which we are using in the main method. So there are certain scenarios in which a class gets loaded. For example, when the program starts up. As we just discussed, the JVM will load that class which is required by the program to start its execution, which is basically the program's entry point, usually the main method. So JVM will load that class in order to start the execution of the program. Number 2 is when an object is created. When we use the new keyword basically to create a new object, at that point of time, JVM will load that class into memory. So when we are creating a new object of a class, it's a hint to JVM that please load this class and create a new object. All right. Number 3 is when we access a static method or a variable of a class. So somewhere in the program, if we set something like my class dot counter or my class dot run my static method. So if we are accessing a static method or a variable on a class, it's a hint to JVM that please load this class. All right. Next point is when a class is extended or implemented. So let's say we have a subclass that extends a parent, or if it is implementing the interface, and if the JVM is loading this subclass, at that point of time, it will also check the hierarchy and it will load the parent class or the interface into the memory. And the last thing is when a class is explicitly loaded. So we can use methods like class.forName to load a class dynamically at runtime. And if we are using class.forName, then at that point of time, JVM will load that class. All right. So we know how Java loads a class using class loader, and now we know when does a class get loaded. So let's see what happens after that. Let's talk about the class loading mechanism. In this section, in the class loading mechanism section, we will see how a class is actually loaded by a Java class loader. So we talked about multiple class loaders like Bootstrap, extension, application, app class loader or system class loader, and the custom class loader. The important thing about class loaders in the JVM is that they are organized into a tree hierarchy, which means in this tree, Bootstrap loader is at the top, then comes the extension class loader, then comes the application class loader, and then comes the custom class loader. So when JVM asks a class loader to load the class, what that class loader does, it checks if it has that class already loaded. If not, it delegates the responsibility to its parent class loader. Alright, so it always checks whether the parent class loader can load or already has loaded that class, the required class. Something like this. So when we run a Java program, it means JVM has found the class which has the main method, the entry point of the program, and now JVM wants to load that class. So it will call the Java class loader. First comes the application class loader. Application class loader will check if it has already loaded the class. If yes, then it will simply return that class and that class will be instantiated by the JVM and it will be executed by the JVM. If it finds that it does not have that class, in that case, it will ask its parent, which is the extension class loader, to see if extension class loader has that class loaded. So extension class loader will also check its own cache if it has loaded that class. If yes, then it will simply return that class and that class will be used by JVM to execute basically the code that we have written. If the extension class loader does not find the class in its own cache, then it will simply delegate the responsibility to its parent, which is Bootstrap class loader. And now it's the responsibility of Bootstrap class loader to check in its own cache if it has already loaded that class. Again, if it finds that it has loaded that class, in that case, it will simply return the class. If not, then it will ask the child, which is in this case extension class loader, and in turn the extension class loader will ask its own child, which is the application class loader, to load that class. So you see the flow. The class loader will only load a class if it cannot find that class in any of its parents. If it finds a class in any of its parent, then that class will be loaded or returned by the parent class loader. So a class will never be loaded twice in this flow, which is the usual flow. We will see cases when a class can be loaded twice, but the basic flow is that JVM avoids the duplicate loading of a class. So we come to the point where Bootstrap class loader could not find the class, so it will ask the child to load the class. And now it's the responsibility of the application loader or the system class loader to load that class. Okay. And so what application class loader will do, it will try to load that class. If the class gets loaded successfully, in that case, the class will be returned to the JVM and JVM can start its execution. So the class loading mechanism has 3 steps, as we saw here: loading, linking, and initializing. So let's talk about class loading steps. The first step in the class loading mechanism is the loading. Loading is the process of finding the binary representation of a class or interface. And once that binary representation is found, JVM will create a class or inheritance from that binary representation using Java class loader. So that is loading. Then comes the linking. Linking is the process of taking a class or interface and combining it into the runtime state of JVM so that it can be executed. Now, before the linking can be done, there are certain things that need to happen. First thing is verification. So verification ensures that the binary representation of a class or interface is correct. In the verification phase, if the binary data of that class or interface which we are trying to load is not correct, then at that point of time JVM will throw an error. That means the linking cannot be done, and ultimately that class will not be loaded. So that is verification. Second step of the linking phase, which comes after the verification, is preparation. Preparation involves creating the static fields for a class or interface and initializing such fields to their default values. It means in the preparation phase, if the class or interface has static methods or static fields, those fields will be initialized to their default values, not the actual values, just the default values. Then comes the resolution, which is the last step in the linking phase. And resolution is the process of dynamically determining concrete values from symbolic references in the runtime constant pool. It means the class may have, because each class has its own runtime constant pool, and the class will have some references to, let's say, it may call some method of another class or another interface, and in the bytecode there will be field references. So at this point of time, what JVM tries to do, it tries to resolve those references, which involves field resolution, method resolution, exactly which method needs to be called, and super type resolution, which means which interface or super class it needs to access in order to initialize this class. All these resolutions happen in this resolution phase, which is part of the linking phase. So we covered loading and number two, linking. The last step in the class loading mechanism is initializing or initialization. In this step, class loader initializes the class. So at this step, the class will be fully initialized, and that completes the loading of a class. So we talked about loading, linking, and initialization phases of class loading mechanism. Okay. So this is the same thing that we discussed: loading, linking. Linking has three steps: verification, preparation, and resolution. And the last step is initialization, which means we finally initialize the class and JVM can now run it. Let's talk about what if. What if class loader can't load a file? So we talked, let me go back. We talked in this flow that when we run a program, JVM tries to load a class. And because this is a tree hierarchy of class loaders, so what each class loader does, it delegates the responsibility to its parent to check if the parent has that class. If yes, the class will be found and will be returned to the JVM. If no, it will ask again its own parent. In this example, let's say Bootstrap class loader. And if Bootstrap class loader cannot find that class, then it will ask the child to load the class itself. Now the happy scenario is that the child can load the class. In that case, the class will be found and returned to the JVM. But what happens if the class loader can't load a class? In that case as well, if the class loader can't load that class, it will ask the parent to load that class. So the first step of the cycle, or the first cycle, was to check if the loader or if a certain class loader has already loaded the class. Now the second cycle is where class loaders are actually trying to load the class. So if application class loader can't load the file, it will ask its parent to load the class, which is extension class loader, and it will try to load the class this time. If it can, then fine. If not, then it will ask Bootstrap class loader to load the class. And this time, if Bootstrap class loader cannot load the class, then the JVM throws a class not found exception. And this exception indicates that the class could not be found by any of the class loaders in the hierarchy. Alright. Now it can also happen that a class is found by the class loader, but maybe the class file is corrupted. There is some problem with the binary data. It does not have the correct format. In that case, JVM generally throws a no class definition found error or a class format error. Alright. So we need to remember that class loaders have a hierarchy and they will always delegate the responsibility to its parent, whether to find the already loaded class or to actually load the class. Okay. The second thing is class loader. What if class loader finds multiple classes with the same fully qualified name? By fully qualified name, we mean the name of the class with the package name. So if my class is in my package, let's say com.thedumbprogrammer.demo. If my class is in this package, then the fully qualified name of my class will be com.thedumbprogrammer.demo.launcher. Let's say launcher is the name of my class. Now, how does JVM find a class? It scans the directories. Bootstrap knows where the JDK or JRE files are, so it goes to that directory, and whatever archives it finds in that directory, it will try to load all the classes from that archive. All right. Extension loader knows that it has to load the files from the directory that we provide via java.ext.dir's system property. Similarly, application or system class loader knows that it has to scan the class path, which we provide via -cp or class path system property. So ultimately, JVM will scan those directories to load the classes. So it may happen that multiple jar files may have a class with the same name. Now the question is, what if the class loader finds multiple classes with the same fully qualified name? In that case, what it does, if multiple classes with the same fully qualified name are available to the JVM, then to resolve the conflict, what JVM does, it follows the simple strategy, which means the first appropriate class wins. So order matters in this case. What JVM will do, it will simply scan the jars or directories or the URLs in the order they appear in the class path in order to find and load the classes. And in case of the multiple classes with the same fully qualified name, where it finds the first class with the given fully qualified name, it loads that class from there. Alright, it will simply avoid having duplicate classes in the class path from multiple dependencies. So even if in the class path it finds multiple classes with the same fully qualified name, it will load the first class that it will encounter, and the other classes will be skipped to avoid duplicate classes in the class path and into the memory. Alright, so that's a wrap up for the part 1. We covered the basic flow of how classes are loaded in Java, including the Bootstrap class loader, the extension, and the system class loader. In the next video, we will talk about the custom class loaders. Thanks for watching.